So we will see question number 7 and 8 now. And here in question number 7, you will be going through learning a new formula which I haven't discussed with you. As I have been telling you, this particular chapter has a lot of new portions and new formula. I didn't want to introduce all the formula at the same time. So one by one you are getting introduced, and when you use the formula in a problem, it will stay better in your mind. And in this question, actually, let's see the question. The demand curve of a commodity is given by P is equal to 50 minus X by 5. Find the marginal revenue for any output X, and also find marginal revenue at X is equal to 0 and X is equal to 25. So this is the question. They are just given the demand function and they are asking you to find marginal revenue. So when you are given revenue function, normally you will find marginal revenue. But when demand is given, you have to find revenue and then differentiate and then find marginal revenue and all that. But instead of all that, here actually you are asked to find marginal revenue through some other method, that is using the elasticity of demand. There is a formula connecting marginal revenue and elasticity of demand. So you are supposed to use that formula in this problem. That is why they are giving you demand and asking you to find marginal revenue. So demand is P 50 minus X by 5. So dP by dx you can calculate. Actually this is 1 by 5 of 50 minus X. So 1 by 5 into, for 50 it is 0 and for minus X it is minus 1. So it's minus 1 by 5. And so dx by dP will be the reciprocal, that is minus 5. Nu d, the elasticity of demand, is defined as minus P by X into dx by dP. So minus of P, 50 minus X by 5, and there is an X that is supposed to be added here. So X comes in the denominator, into dx by dP minus 5. Minus minus cancels, 5 cancels. So it is 50 minus X by X. Now marginal revenue MR is equal to P into 1 minus 1 by nu D. This is the relationship connecting marginal revenue and elasticity of demand. So if you substitute in this formula, it's 50 minus X by 5 into 1 minus X by 50 minus X, which means when you take LCM 50 minus X, it will be 50 minus X minus X. That is 50 minus 2X, and this 50 minus X can be cancelled. So it is 50 minus 2X by 5. And you are asked to find MR when X is equal to 0 and MR when X is equal to 25. So when X is equal to 0, MR will be 50 by 5, that's 10. And when X is equal to 25, 50 minus 2 into 25, that is 50 minus 50, numerator 0. So the answer will be 0. Question number 8 is a direct problem. You can work it out by just using what you learned already, the formula for elasticity of supply. And so supply function here is given as X is equal to A into root of P minus B. So please remember, both A and B are constants and P is the variable. X is defined as a function of P. So here you have root X model. And P greater than B means this function is clearly defined always. So the differentiation dx by dp is A, the constant, which is a coefficient, into this is root x, no? So root 1 by 2 root x, 1 by 2 root P minus B, into derivative of P minus B. So when P is differentiated you get 1. Then for B I told you is a constant, it will be 0. So A by 2 root P minus B. That is what dx by dp is. So nu s, P by x dx by dp. P by x is A root P minus B into A by 2 root P minus B. So A cancels. P by 2 into root of P minus B into root of P minus B is P minus B. When P is equal to 2B, what is the value of nu s? That is there in the question. So nu s is equal to 2B, substituting P as 2B. 2B divided by 2 into 2B minus B. So 2B by 2B you get, therefore the answer becomes 1.